APIs in general. So when people start with GraphQL, I often see them directly diving into the most complicated topic in GraphQL, and that's distributed GraphQL. The monolith approach with GraphQL is actually much easier, or it's much easier with any API, because it's so much simpler to build. It's just one piece of software, and it's pretty easy just to get started with one project. Think also about debuggability and things like that. So when people get started with GraphQL, my advice is just start with the monolith, but start building it in a way that you can later take it apart. So the problems with monoliths, and people experience that at some point, are that they kind of more difficult to scale. Like you have this big piece of software, and scaling that might be a lot more challenging. One thing here, Facebook actually, their GraphQL server is a monolith. Until today, they have just a very few microservices. So it's also possible to live just with one piece of software and make your engineers do a bit more work. So what is really challenging with a monolith, and that is one of the key pieces why you might not want to stick with this for too long, is that all your teams really have to work with the same technology. And that is one often used reason to really not go with that. And as I said, it's difficult to scale. So let's talk a bit about scale, because I think often people mistake why they should really go for distributed solutions here. And that's not the scale you think about. So when we talk about scaling APIs, it's really three axes that we talk about. It's data, throughput, and developers. Let's first talk a bit about scaling data. So when we talk about scaling data, we often mean putting the data more closely to your people that want to use it. So in this case, we would talk about partitioning or sharding. And sharding is really a method for distributing your data across multiple regions, machines, disks, or whatever. So it's really about making sure that the people that are in Germany get to the data that is located in Germany. So you want to locate the data close to your people that are using it. But when we talk about scaling, most people actually think about throughput. So when we talk about throughput, it's actually about a lot of requests that are hitting your system and you want to scale it out. And that is a problem with the monolith. Because when you scale a monolith, you scale always the whole thing, and not just the parts of it that might be under pressure. But I would say 5 years or so back, people went all insanely on microservices. So everybody would create a microservice architecture. And it's great. With microservices, I finally can distribute technology or use the technology that I want in the team I want to use it. So each team could use their framework, one team maybe .NET, one team JavaScript, and what have you. Also, microservices are more resilient and easier to scale. So you're, in essence, more flexible with this approach. But there are a lot of cons with microservices. One for me very difficult is that it's difficult to consume. Like, which microservice do you ask for what? And most of the times when we talk about proper microservices, they're very small, do really one task and one task well. But when I look at most of the architectures I see out there, we are really talking about domain services. What we also have to think about with microservices is network latency and data consistency, as every microservice or domain service owns its own pot of data. And that's great, because that goes hand in hand with sharding I mentioned. An approach that many companies try to use, Netflix for instance, they started with the BFF approach already 10 years ago. And that would essentially counter the effect of the microservice. You would build for each of your client devices, like for mobile devices, for desktop devices, one BFF. And BFF here does not mean best friend forever. It's actually backend for front end. So we have a backend for each front end that we build. And this backend would provide the perfect API for this front end. So every client has a specific API. And that is easier to consume. And we could put that over our microservices. But with BFFs comes a lot of code duplication and also high maintenance. And what I mean with that is also that if you think about BFFs for each of your applications, that you have to maintain a certain stack, and also you don't get the flexibility of the microservice approach that you were aiming for. Because now this BFF has a logic how to communicate with the microservices behind that. Meaning building or changing these microservices behind it always essentially always forces you to also maintain this piece of BFF. And that is where GraphQL really came in. And not distributed GraphQL, but GraphQL as a whole. Facebook actually deployed GraphQL as a monolith. But when GraphQL was released, people used it kind of as a gateway technology. So GraphQL gives me really the one unified API that every of my clients can use, because every client can pick and choose the data it needs from that unified schema. And with unified schema come proper typed entities. So when we talk about microservice or distributed services and then bring GraphQL into that, then it really compensates for all the shortcomings that you have in the microservice world, because we have now combined entities. So the user entity is one thing and not shared across services. And also the connections between these entities really give my graph meaning. So I can explore and dive into my GraphQL graph and pick and choose the data I need. For instance, when I do a request from my mobile device, I might just need a little bit of data. Like let's say we are fetching the products of my online store. And then we just need the name and maybe the profile picture. But for my desktop device, I also always want to fetch the reviews in one go from my GraphQL API. GraphQL gives me the flexibility to do just that. And since we're using GraphQL in front of our microservices, we can now scale our product catalog or our review or our payment service. And that is a great approach for users, but still has some shortcomings. But with GraphQL, we finally can put this thin layer of GraphQL over our existing infrastructure and make it easier to use. So when we do this request to our product catalog, we are really using some of these microservices and just have to scale this little piece of software. And if we use our mobile application, then we use maybe more of our microservices behind that. So we are effectively using GraphQL as a gateway technology here. And this gives us, as I said, a unified API and scales only the part of our infrastructure that really are under pressure. And finally, we can work on our microservices in freedom. But we still have difficulties in deployment, and we have to hand optimize our resolvers. Resolvers are the pieces in a GraphQL server where I really fetch the data. I have to hand optimize that. I have to analyze what my users really do over my GraphQL layer, and then introduce optimizations, hard-coded optimizations. And this still doesn't give me the flexibility to scale my developers and distribute them essentially across projects I have at my company. So when we talk about distributed GraphQL, we are really talking about making GraphQL scale in the sense that all your teams can work without coordinating, really. You coordinate on the schema, but you don't have to ask the other team if you can deploy because you're changing something on your microservice. You can just deploy it, and it will compose a GraphQL gateway automatically. So instead of putting GraphQL over our microservices, we are putting GraphQL over our GraphQL domain services and compose from that a GraphQL gateway. And with that approach, we can even go further and say we have each team owns a certain subgraph in our data graph. And behind that subgraph sit some microservices that this team own. And that makes them really independent from the other teams. As I said, we still have to negotiate on the overall schema. So since we are building one data graph, we still have to coordinate on that. There are two approaches in GraphQL schemas, in distributed GraphQL. One is called schema stitching, and one is called federation. There are tons of implementations for that. We have Apollo schema stitching, Chili Cream schema stitching, that is essentially the .NET variant we built. There's Hasura remote joins. There is GraphQL Mesh from the Guild, and many, many more. And also for federated approaches, there are tons of implementations to implement a distributed GraphQL schema. So let's talk first off about schema stitching. That is the original approach to distribute GraphQL. The GraphQL schema stitching approach is mostly imperative, so you have to write code. We try to do a declarative approach, so it could also be done declarative, but it's just kind of. And subgraphs can be transformed with the schema stitching approach. But it still doesn't give us the freedom that I promised, because the configuration for such a gateway is centralized. The composition is at runtime. Composition means the process of merging your schemas into one graph. And that means you still have this one bottleneck in your deployment. This is how the Apollo schema stitching would work. You essentially write merging code for your GraphQL types, and then the gateway would compose this. But you're writing code, and that's kind of not cool if you want to distribute your workforce. We did something similar. We did it declarative, but still we had this delegation passes here, and that's kind of an imperative approach that you can annotate. So not good. So 2 years ago, I would say, Apollo started with the approach that they called federated. And that allows you to decentralize the configuration of your federated GraphQL schemas. Instead of writing code or writing these strange annotations, you would with declarative annotations define what parts of your schema are distributed and give them properties like is some piece of data shareable and stuff like that. The composition would be done at build time, so you fail early if your graph cannot compose. And on top of that, they introduced a concept about query plans, which optimize the data fetches for you. So you don't have to think about resolver optimization that we would have to do with schema stitching. But we also went back kind of what we could do with schema stitching. We cannot transform subgraphs. So if one team has kind of a different naming style guide or something like that, then they cannot do that. So each team still has to align on naming, still has to align on general data structures, and they don't have the full freedom to build their graphs as they want. And also subgraphs are specifically made for one data graph. And you need to follow a GraphQL subgraph protocol for Apollo federation. That means you have to have in each GraphQL implementation an Apollo federation integration. And that means when they are upgrading their versions, you have to be sure that all the providers that you're using really support that and support that in time. It's also difficult to implement GraphQL features with Apollo federation and to use the GraphQL best practices. So you cannot use just subscriptions, or the relay patterns are not possible. This is an example of Apollo federation. We have here some annotations like override, shareable, or what the key of our entity is. But really, GraphQL is so expressive that we could infer that from our schema if we done it right. And also, each subgraph has to have proprietary fields to expose what schema is there and have these kind of ugly fields there, this entity field, where you can pass in any data representation to essentially fetch some data. So you're not doing really GraphQL in your subgraphs anymore. That's why we thought we should rethink this approach of distributed GraphQL. And we call that GraphQL Fusion. So GraphQL Fusion has zero configuration. And I also wrote that this configuration is decentralized. How does it fit together if it has zero configuration? So basically, for you as a developer, we have zero configuration. But as soon as you pack a subgraph, we will infer the configuration from your GraphQL schemas, because they are already expressive enough to distribute a schema. It's fully declarative, and that means you can hint the GraphQL composition engine what you really want with that type. Composition is possible on build time, and that's the preferred way, but also at runtime. And it also supports query plans to optimize what you want to fetch. Subgraphs are valid on their own. They are their own valid schemas. You don't have to hide them behind a firewall like with Apollo federations, because we don't have these custom fields where you essentially can dangerously query your GraphQL entities. And subgraphs can be transformed, so you have all the capabilities of schema stitching. It also embraces all the GraphQL features that are out there, like subscription, and all the best practices, like the relay patterns. And we automatically utilize overlapping data, and that allows us to really use sharding and partition concepts in our microservices. So Fusion is a more natural approach to distributed GraphQL. Let's have a look at that. And I have to take my other hand here. So bear with me. Okay, this is a basic setup. Let me make that a lot bigger. No, other way. Yes. Okay, so in my example here, I have two subgraphs, accounts, reviews. So accounts are all the user data that I have, and reviews are the reviews for my products in my store. I don't have the products subgraph yet. So let's maybe just start the account subgraph and explore it a bit. So I prepared that, so I just have to press enter here. And then let's have a look at how that looks like. There we go. So I'm using Banana Cake Pop, that's our GraphQL IDE. Okay, let me zoom that in. And I already have here a tab for accounts. That's my accounts API. I can refresh it. So I get a new schema here. Click it. And then we can have a look at the schema. So let me put that to the side. And you can see it has a query here, and I can dive in. And I can see that I can fetch here a user, or I can fetch multiple users. And if I go into the users, I have a couple of information about my user, like the birthday, the name, and the username. So all what an account service really needs. I can also go to my second service, and that is the review service here. Also refresh it, and then we can dive into the schema, and you can see, let me put that away, that I have a couple of fields here, like review by ID, reviews, and I also have users here. If I go, for instance, in the user type here, you can see that my user type has also a name, has an ID, but also has a reviews, but it doesn't have all the other detailed users. So my subgraphs or domain graphs here have overlapping data, but they also have their unique data. And also the meaning is different here, because in one service, it's a user account, and in this service, it's really the author of my reviews. Let's maybe query it and see what happens. So I'm going here to my account, and in GraphQL, if I want to query something, I have to come up with a query. So I'm writing here a small query, maybe to fetch the users, nodes, and then let's just fetch the username. Damn it. Fetch that, and you can see I get here 2 users. Okay, that's brilliant. So how would I make that a distributed setup? So in my VS Code instance here, I can go into the console, and I already installed some GraphQL templates here. So if you do .NET new install hot chocolate templates, then you get all our GraphQL templates. And then I just can say .NET new GraphQL gateway, and I get basically a gateway template. It doesn't have anything with authentication set up, but that's the job of the person who manages the gateway. So what we have here is basically one thing. We set up there the HTTP client factory. We could add poly to it to make it more resilient. And then we have there a WebSocket factory that we provide. You could also make it resilient. And the basic piece is here the Add Fusion gateway server. And it refers to a file, and we call that file the Fusion graph. Okay, that Fusion graph doesn't exist yet. But still, let's run that. Run our gateway. And at the moment, the gateway is just empty. So in order to compose a Fusion graph, we have to use our Fusion console. It's a .NET utility. I already installed it here. I said everything is running at build time. So we have here the Hot Chocolate Fusion command line. That's a .NET tool, and we can just run it. And I target here my gateway and the subgraph. And it will extract from the subgraph all the information about the subgraph, analyze the entities, and build a distributed gateway for it. So I did that. And this thing is hot reload. So I can just go now here to my gateway. Let's go here. And if I look at that, let's have a look at the schema. Then you can see here the schema is essentially the same that we have on our subgraph. So we have users, and it's not something exciting at the moment because it's the same than our subgraph that we have. But I can query now through my gateway. So let's make it more interesting. So let's add the second subgraph to it. So I'm going here. Just enter it. I prepared the commands so I don't have to type too much. Okay, so my subgraph just changed, or my gateway graph just changed. I can refresh that here, and we can go in here. You can see there's a lot more to it now. And what our command really analyzed is that this data is interconnected. So I can see here, if I drill into my user, you can see it now has reviews. And we can also query that. So now I can go from my user here into the reviews and get the review nodes and then get the body. And you can see now I'm querying actually from 2 servers. So let's go here. Let's have a look at the reviews. You can see I'm querying here from the review graph, and you can see it's also in a batched fashion. And here you can see that the data is really queried from my accounts graph. And the gateway is just distributing HTTP requests between these. And we also support GraphQL over gRPC. That means that we can also optimize, fetch these data when you are in your production environment. Okay, let's close this demo one. Okay, it's going better than I expect. Okay. And let me just get rid of that. Okay, so what we just did is we took 2 graphs with different shapes of the user. So the user in different versions, you could say. In one, it's really the author, and in the other one, it's our user account. And we merged that. And now it's one type. And that's nice to explore. As I said, we take the complexity of microservices away and compensate for all the distributed data and bring it together in one graph. And suddenly, the microservices become easy to use. So how does it work in a build setup? So what we want to do actually in a proper distributed graph, we have maybe 10, 20, 30 microservices or domain services behind that. If you think about Netflix, I think they said they have 130 subgraphs. So how do we do that in a build pipeline? So it's very easy. We basically build our subgraph, compile our subgraph, and then run this composition command that I just run in my console. And that will pack a subgraph configuration. It will infer from your GraphQL server, and it doesn't matter what GraphQL server you're running, it will infer that from that, pack it in a subgraph configuration, and then we can deploy it. The deployment pipeline would first download from the gateway the current configuration. And in the current configuration, we actually have packed all the original subgraph it was composed of. We also have the public schema in there. And we would then compose with the subgraph, with the Fusion graph configuration and the new subgraph configuration, a new public schema. And then just deploy and upload the GraphQL configuration to our gateway. So let's talk a bit about query plants a bit. And to understand query plants or what they really do, let's have a look at code. So this subgraph here, or this gateway and its subgraph, really is a couple of iterations ahead. We now have accounts, we have products, and we have reviews. So our gateway is already set up, and I'm good to start it. So let's just start our gateway here, start our subgraphs, and let's already have a look at how query plants really work. So this is coming up. No, I don't need to. I'm going over here. And let me choose down here the demo 2. Okay. So I already prepared here a more complex query. And let's refresh the schema quickly. Okay, so what we are doing here is actually using a ton of data. So we first query the reviews, all the reviews in our system. Then we get some author data, so basically user data, and then we query into the product catalog. So what would happen here? Let's just run it. And you can see it takes the first time a bit to start because I have to warm up 4 machines, but after that it's pretty fast. And there are proper databases behind that. And yeah, data looks good. But how can we see that it's really good? So I have here a header that's GraphQL query plan, and I just enabled it. And in a development environment, it gives me the query plan of this request. Should. Let's quickly see. It doesn't. It was not on. Let's query again. Go down here. Or make that smaller. You can see here's the extension data. That's a place where GraphQL servers can put extra data that are not in the GraphQL spec. And we put here the query plan. And what we can see here, that is a document, the request that got in. Then we have here a sequence. Come here. And this sequence has a couple of things. So the first thing is here, we are going to the reviews graph. And from the reviews graph, we are getting all the reviews data that we can get. You can see we are getting also the author because the reviews graph, if you remember, has also the name of the user. So we don't have to go to the user graph. We can get that from the reviews graph. This is with overlapping data. Get the data where it's most efficient to get from. And then we are exporting here an ID of the product because we don't have the product on the review service. And this we take and batch here. You can resolve by key batch. So we take the key of the review of the product and we batch it into the next thing. And that is our products graph. And from there, we get all the products data we need. And at the end, compose the result. And that's what you see. So it's super efficient to fetch with that. But let's have another query here. So let's run this query. And that is essentially the same query, but the other way around. So from the products graph. So we get data. But when we look at that, you can see here's a resolve. So we get the data from the products graph. And then we have another resolve. And that means it's basically for each ID calling the other subgraph. Let me show you that in the slides. So when we do this request, we actually have a query plan that goes to the first subgraph, gets the initial data, exports this ID, and then does it for each over the IDs and gets hundreds of requests. And that's when the other subgraph is not optimally built. So our review subgraph has no way to batch fetch essentially the reviews by product. But we can optimize that. So let's do that. So what we can do here is go into our products graph, into our query type. Oh no, not the reviews graph. Into our query type. And then we're going to add a resolver here. And this resolver, okay, it's fake, just creates an object here. Usually we would go to the database, but for the demo, bear with me. But what I'm doing here is I am just providing an extra resolver. And that's what I mean with, we are doing it with proper GraphQL. You don't have these internal fields that fetch GraphQL in a not GraphQL way. We are actually introducing a proper resolver that allows us to batch fetch products now. And then we just have to do one thing. We kind of annotate this for our GraphQL engine. That's the hinting, I mean. So we could hint here that there is a products by ID field, and the IDs array is actually semantically the products ID. So with this done, I can just compose my graph and then go back, rerun this thing, and have an optimal fetch now. And you see, I never restart my things. They are all hot reload. So even on production, you never reload or restart your gateway. It always runs and is super high availability. Okay, so what we can see here is now we have sequence, we have an initial result from the products graph, and then we have here now an optimal fetch with a batch. And it's just 2 HTTP requests. Okay. So there you can see that our new query plan essentially, where we just have 2 fetches and some composition. What is with GraphQL real-time? Many people want to distribute GraphQL, but they also don't want to lose the features. And it's super complex to do GraphQL subscriptions on their own, but to do it distributed is super complex. So let's have a look at how we can do that in our GraphQL setup that we have here. So what I want to do is, I have a simple mutation here in my graph, and that's create reviews. And I want to have a subscription that triggers me every time a review was written. So I will create here a second instance of Banana Cake Pop. And there we have a subscription that we want to call on. It doesn't exist yet. This guy here. And to add that, we go into our code, go here into this empty subscription file, and I'm just adding a subscription to it. So this is my subscription. What you can see is we are listening to the create review topic. And every time this topic is raised, we get here an event message. That is the review ID. And we use a data loader to fetch that from the database and return it. And that is a real-time event. And the next thing we have to do is just to compose it. Same command I did before. And now our GraphQL server should be real-time. Let's have a look at the schema quickly. And go here. And you can see we have now a subscription type, and here's our event. But does it work? Let's see. So I'm gonna... It's really difficult with this finger. Okay. So I'm going to run that. You can see it's not immediately executing because we are waiting for something to happen here. And the next thing is we go here to our, let's rearrange that a bit. We're going here to our other instance, other application instance, and I'm creating here a review. And boom. It's real time. So you don't have to do anything because we understand all the GraphQL subscription protocols. There are 3 major out there. There's GraphQL WS, there's Legacy Apollo protocol, and there's GraphQL SSE. All of them work automatically. We will figure out what works. And not only on the gateway, we also automatically figure it out on the front end. Like we could just say auto. Stop that, rerun that. And then, yeah, it's always the same stars. I should probably raise them, and you can see there's change. So that's what I refer to as zero configuration. Okay, let's talk a bit about best practices in GraphQL. And there we always have something that is called the relay schema pattern. And the relay schema pattern is also how to build GraphQL as an enterprise scale. It's how Facebook builds GraphQL. Let me show you an application example, because it's always good to understand why we do these things. So this is an application we actually use. Oh, no internet connection. 1 second. I will tether. Okay. Okay. Give it a second. Okay. So this is a pseudo cryptocurrency market. It was a good example 2 years ago, but now. Okay. So what we have here is a crypto marketplace. We have top gainers and we have top losers. We have some slides here. I can go into certain cryptocurrencies, and it's all real-time updating the prices. So when I look into the developer console here, let me just quickly do that. A few developers. And then show you what is really happening on the via GraphQL. So let's refresh that. So what you can see here is that we actually have one GraphQL request. This is just a pre-flight request, and this is a WebSocket. This is a WebSocket to essentially receive these real-time updates. And really, if you work with an application that uses GraphQL, let me clear that for you to see that, you ever only have one request for everything. You can see, no matter what I do, it's always a single request, because we have the ideal fetch with GraphQL. You never get more requests than just one. And now I don't have requests because my application has an intelligent cache here. But the thing about the requests, let me clear them, is that we have something that is called the node pattern. So when I do the first fetch, let me just copy that here, copy as curl, and then we can use banana cake pop and paste that in here. And this is actually the request that we do to fetch the data on the client application. It's a ton of data, and I can scroll here forever because it fetches a lot of data points. You can see over 1,000 lines of JSON. So when I go back to this thing and I click on this, it just fetches the difference of data that is now needed for this request. Let me fetch that again. And what these client applications actually do is the following, and then the patterns make sense for you, is they use a field that is called the node field. So what you can see here is that we only fetch the parts of the data that we really need to update the screen. In this case, it's the percentage change. You can see these history points that are the price points over time that we refetch. And if I look at my distributed GraphQL here, then we don't have that yet. This guy here. And then go in the schema reference here. So when we go into here, you can see there's no node field. And for distributed GraphQL, it's very complex to do that, actually. That's why Apollo didn't implement it until today. But we made it really easy to do that. But let me show you how we implement that, actually. And then I tell you why it's so complex. So in order to compose a graph with the nodes pattern, we just say enable nodes. And it doesn't matter if you implement the nodes in your subgraphs or you have different node names even in your subgraph. We figured that out and implement it for you in the gateway. So I'm running this composition command here. We can go back to banana cake pop and refresh that. And then you see here we have now implemented the nodes pattern. But let me show you why that is so complex. So let's wipe that out and write a single request here, query. And then we go into a node here. And you can see the first thing is a node has nothing to it because it's an interface. And when I want to fetch something from that, I have to use an inline fragment here and say, OK, I want to fetch the product. And that actually would be easy for the query plan engine to figure out, OK, we are going to fetch a product, so it's easy. Let's fetch the product. But I could also say, but if it's a user, show me the birth date, or show me the username, or whatever. And what makes it really difficult is that I can't feed into this here any ID. So it's not clear if it's even the two things that you specified. It could also be another ID for what you have no fragment in here. So the query plan kind of is defined, at runtime. And that is difficult. But we compile it actually at the time we compile the query. And let's just fetch. I need an ID. Let me just go back 1 second. OK, let's just fetch here a product ID. Do we have one? Wrong query. This guy. Now we have a product ID. Damn it. Let's just fetch that here. Yeah, it's painful to watch, but no. It's really 2 fingers. Okay, so I leave it at that because that is enough for you to see the execution plan here. I'm switching on here the query plan header, so we get the plan. And what we do is we have a sequence here. We know, okay, that's a node what you try to resolve. And we kind of have here branches. So the query plans can have essentially if clauses, if you want, or switches. And what we're going to do is, if the ID is a product ID, we're going to send this query to this subgraph. If it's whatever other ID, we're going to send it to whatever other graph. So we kind of build these switch case plans, and then it's super efficient and works quite well. And again, zero configuration, it's just an argument at build time. Okay, let me go here. That's actually it. It was a bit not so well, but anyway. If you want to follow us, everything here is open source, by the way. It's under the MIT license and will always stay there. And you can follow me. And if you have questions, I'm ready to receive them. Oh, there was Irina showed me a mail where you could have feedback. Let's see. I don't know if I find it, but Speakers Lounge. Okay, thanks. This guy? Yeah. Yes. If there is no question, then it's is this guy? Okay, there's no question. You can also ask in voice. I don't mind. Apart from that, we are done. So. Yes, it's on the GitHub. And you have the infrastructure configured? Yes. It's also like that. That is good. I also wrote a README with all the steps that you have to do. So there's a demo 0 even that really talks you through how to do the subgraphs. It's, damn it, why did I plug it out? Will it work when I plug it back in? There is so let me throw that here. Do we get it back? Let's see. No? Can you put the screen back on? Ah, thank you. Okay, so what I have done here is GitHub, caps lock off, and I have to again go to my phone. Okay, so under Chili Cream, view organization. Under Chili Cream, we have these hot chocolate fusion examples. That's the repository. And you have here 3 demos. That are the 2 demos I used now. But you also have this demo 0, and this also describes all the steps that you need to run if you really build it from the bottom up. So you can follow them and really build all the way to the end like I did. It's 3 things. And yeah, as I said, this is MIT. You can also help contribute to this. We are launching, so that's a preview. We are launching it in August, and it will run, like the gateways will run with AOT compilation. That means they are pretty fast. You saw here request times of around 30 to 20 milliseconds. When we compile it into AOT, we can see 6 milliseconds, so it's a lot faster. And if you're interested in the source code of this whole engine, it's here in the hot chocolate section on our repository, and then you have here Fusion, and that's where everything lives. Other questions?
Yeah. So, what are the 3 main design recommendations or considerations that you argue to go with GraphQL instead of?
Yeah, with GraphQL. So the first thing, start with the monolith. So I would really do that. So the first thing, start with the monolith and build a simple thing. Because most times people start with GraphQL and they really have struggling with the concept in GraphQL. And there are a ton of concepts. Like also, what many people think is that it's something like OData. But GraphQL is really a way to build the most efficient REST API. Most people don't get that. Because when you hit the deployment button with GraphQL, you would use something like persisted queries. So at development time, you are building GraphQL with your nice applications. You have all the freedom that you have with GraphQL, and then you hit the deploy button. We would strip all the GraphQL queries from your client, upload them in the server, and then you just have hash communication. Let me show you one thing. So Twitter is, for instance, using GraphQL. And now I have to find somebody to like. 1 second. So developer tools. Let's get that out. Clear that away. Ah, Bogdan, we can like that. So you can see this is a GraphQL response shape. But if I look at the request here, then there's no GraphQL query. There's just the hash. That's how GraphQL looks deployed. Super secure and super fast. That's how, when you look at, many people think, for instance, that graph.facebook.com is their GraphQL API. No, it's a REST API. They have a GraphQL API, but it also looks like that on deployment. And that's what I mean. First learn GraphQL, how to properly deploy GraphQL, how to properly use GraphQL, and then look into distributed GraphQL because that's the most complex part of it. It will set you free once you mastered this, but there are a lot of things that are ongoing with GraphQL. But yeah, Like the distribution part of it then is very easy. Like all these concepts like persisted queries, you can just switch it on in the gateway as you can do it with Hot Chocolate GraphQL server. So that's my recommendation if you start with GraphQL. If you do GraphQL already for 2 or 3 years, you have multiple teams really, then go for the distributed approach. If you just have one team of developers, just build a simple GraphQL layer over your infrastructure. It's also more team. When do you have to distribute your thing is when you have more than one team. Then I would distribute. Is that a good answer? Other questions? I have time. 4 minutes. Okay. Cost. Cost running GraphQL. It's the same than REST. Like there's a cool study from the University of Sweden. They wrote a master's thesis on this, and they looked at running a server with standard ASP.NET Core versus a server with Hot Chocolate, and they found out that the Hot Chocolate server would outperform the standard REST APIs with the Microsoft API. So you have less cost in compute. But only if you do it right. If you do it with persistent queries and stuff, and then it would... do we have the study somewhere, Martin? I don't know. I got the study from Microsoft, actually. They sent me that. But I can put it in the repository. So it's actually not higher than with REST. That's so. But the learning curve is higher, right? Because REST we all know. And when you start with GraphQL, a lot of the .NET engineer actually say, is it something like OData? And it has nothing to do with that. And but it's when you look first time at it, it appears like that. So when I started with GraphQL, it was actually at a project I was consulting at, and the team lead said to me, figure out GraphQL. And I looked shortly at the documentation back then and said, it's OData from Facebook. And that's not the case. It's far more powerful. GraphQL has interfaces, unions, has a proper type system that has more type constructs than you have in C#. So GraphQL is a way to model your business concerns in a much better way than you were before. You don't have to have the compromises that you have with OpenAPI. You can take all the type constructs that you use in your domain layers and really expose them over the wire to your front-end engineers. And the moment you hit deploy, it becomes a REST API that looks like the one I showed you with Twitter. And it's super performant. Like all the big internet companies, like Facebook, Netflix, Airbnb, Twitter, they all run on GraphQL. So it's, if you want a pure scale and also the best developer experience for your front-end engineers,